So for problem 9, it says, given the following graphs, do their respective functions have an inverse? Now, I just happened to give you the function value f of x equals x squared, but you really don't have to be told what this function is to determine if it has an inverse. The thing is, if it has an inverse, it has to be a one-to-one function. So it has to be a function. Notice I've already, since I called it f of x equals x squared, we know it's a function. But to be honest, it has to pass the vertical line test. And that's what makes it a function, but it also has to pass the horizontal line test. And that's what makes it a one-to-one function and makes it have an inverse. And look, this parabola does pass the vertical line test. We already knew that. But it fails the horizontal line test because it intersects the graph in more than one place. So this does not have an inverse. F of x equals x squared, as it is, does not have an inverse. But now look at the next one. F of x equals x squared. But if we only look at x functions, f of x, that shouldn't say f of x greater than or equal to 0. I'm going to fix that. That should say x greater than or equal to 0, which gives us only the right side of the graph. And notice that passes the vertical line test. It passes the horizontal line test. Any horizontal line only intersects the graph once or less, and so passes both of them. So yes, the second one, f of x equals x squared, where x is greater than 0, does have an inverse. Alright, so for the next t function, f of x equals 2x minus 3, again, keep in mind, you're not required to know what the function is. If you have a graph, you can tell if it has an inverse if it passes the vertical line test and it passes the horizontal line test, which makes the function one-to-one, and that means it has an inverse. So, a straight line passes the vertical line test as long as it's not a vertical line, but look, it also passes the horizontal line test as long as it's not a horizontal line. To pass the test, it can only intersect the graph one time, not more than that. So yes, this straight line has an inverse. On the other hand, this polynomial x to the third minus 4x squared plus 2x plus 1 passes the vertical line test, but look, it fails the horizontal line test right there. And if you can come up with just one horizontal line where it intersects the graph more than once, that means it fails the horizontal line test. It also means it's not one-to-one, which also means it has no inverse. So this particular function does not have an inverse. Alright, if f of x is x over 4 and g of x is 4 over x, the question is, are these inverses of each other? They are reciprocals of each other, aren't they? X over 4 and 4 over x, but are they inverses? How do you find out? Well, the check for inverses is you calculate f composite g of x, and you're supposed to get x, and you calculate g composite f of x, and you're supposed to get x. That's what you're supposed to do. Well, another way to write f composite g of x is f of g of x. In other words, I'm supposed to plug the g of x function in for the x for the f of x function. So I'm going to remove that x right there, and what I'm going to put in that spot instead is the whole g of x function. So picture that. So like we talked about before, if you write the outside function down, which is going to be parentheses over 4, and then you put the second function inside that, which is 4 over x, that's what you have. Now how do you simplify that algebra? Well, you say 4 over x divided by this 4, right as a fraction, over 1, which gives you 4 over x times, we're supposed to flip this, 1/4. The 4's cancel, so it looks pretty promising, except you get 1 over x, which is not equal to x. So these are not inverses of each other. You know what? You don't even have to check the second part, because if the first part fails, if you don't get x, then they're not inverses of each other. If you want to check the other one, it works very similar to what we just did, but it's not required. Now for problem 11, I want you to calculate the inverse of the function. So this is when we follow the steps. First of all, is the function one-to-one? Does it have an inverse? Well, if it doesn't tell you it's already one-to-one, then you know by looking at the graph. We know what square root of x looks like. Notice that does pass the horizontal line test, so it does have an inverse. That's step 1. Does it have an inverse? Step 2 is you rewrite the function as y equals the square root of x. Step 3, you switch the x and y values. So x equals the square root of y now. So again, this is the switch step. Then you solve for y. Now to solve for y, I've got to get rid of that square root that's over it. So I'm going to square this side. The colors didn't change. And I'm going to square this side. Now when I square the left side, I get x squared. When I square the right side, the square root and the square cancel each other out. And there I am. Y equals x squared. You can switch it around if you like. That is my inverse. So I have f inverse of x is equal to x squared. Now I'm also supposed to check it. Your last step is to check your results. Okay, so to check this, I need to take my x squared and, well, let's do this. So I'm supposed to calculate f of f inverse of x, and I'm supposed to calculate f inverse of f of x, and in both directions it's supposed to equal to x. So if I calculate this one, I'm supposed to plug in my answer into my original function. In other words, that'd be the square root of x squared, which is x. When I calculate this one, I'm supposed to take my original function, which is the square root of x, and plug it into my inverse function. So that's going to be the square root of x squared. Notice the difference. Here's the square root of x squared with the x squared on the inside. On the inside of this one is the square root of x. But they both cancel to give you x. So yes, these are inverses of each other. So the answer is f inverse of x equals x squared, but we also did the check. So our next problem, 3 over x plus 4. Now what I should have told you about this one, and I will add this, is that this function is 1-to-1. We actually don't know how to graph this function, so I need to tell you that that function is 1-to-1. Once you know that, then you can start your steps. The first step is you replace f of x with y. The next step is you switch x's and y's. So y turns into x, and this x right here turns into y. Then you have algebra. Next we want to solve for x. Well, solve for y. Listen, I can't solve for y if it's in a denominator. So what I need to do is multiply both sides of this equation by y plus 4 to get the y plus 4 out of the denominator. Now on the left, that gives me, if I write it clearly, y plus 4 times x is equal to 3. Now I need to distribute that x inside because I'm trying to solve for y, right? So I can't have these parentheses. So that gives me xy plus 4x is equal to 3. Now I'm solving for y, so let's subtract 4x over. So I have xy is equal to 3 minus 4x. And then I'm solving for y, so let's divide everything by that x. Just like that. So then my final result is y by itself equals 3 minus 4x over x. And I'm supposed to write it in proper notation, so it'll be f inverse of x is equal to 3 minus 4x over x. Now that's probably my answer, but I should check my work. So when you check it, remember you take your answer and plug it into the original function. So if I calculate f composite f inverse of x, that's going to be equal, I write the outside function down first, that's 3 over parentheses plus 4, and my inside function is going to be my inverse, which is 3 minus 4x over x. Now I have a lot of work to do to simplify this. Okay, so I keep going. That gives me 3 over. The only way I can add these together is if I find a common denominator. Well, to do that, I need to multiply 4 over here by x over x. Okay, so that's going to give me 3 minus 4x over x over here plus 4x over x. Now I can add these together because I have a common denominator, which is going to give me 3 over, 3 still on top. Negative 4x plus 4x is 3 over x. Keep simplifying. I'm going to invert and multiply by that. So that's 3 times x over 3. These 3's cancel to give me x. So the one direction worked. I'm going to do the other direction in green. And we're calculating f inverse of f of x. Okay, so the f inverse is on the outside. So for each one of these x's right here, I'm going to replace it with my original function, which is 3 over x plus 4. This is going to give me 3 minus 4 times 3 over x plus 4. And in the denominator, I have 3 over, right here, 3 over x plus 4. Getting carried away with it. Do you see that? So both of these x's, I'm replacing with my original function. Now what I can do on top here is multiply those together. So that's going to give me 3 minus, that's going to be 12 over x plus 4. In the denominator, I'm going to keep my 3 over x plus 4. Now my next problem is I have these two separate fractions. I need to add them together. Well, to do that, I need a common denominator. So y'all, I'm going to multiply the 3 by x plus 4 over x plus 4. That way they have a common denominator. So that's going to give me, now distribute here, that's going to give me 3x plus 12, and then minus 12 over that common denominator of x plus 4, divided by 3 over x plus 4. Okay, now I had a typo here. That looks like 3 plus 2. That's supposed to be 3 plus 12. There we go. When we distribute the 3 inside, now this plus 12 and this minus 12 cancel each other out. That gives me 3x over x plus 4. In my denominator, I have 3 over x plus 4. Now my next step is going to be to flip this and multiply. Okay, so watch this. That's 3x over x plus 4. That's in my numerator times x plus 4 over 3. Now let's cancel common factors. So you see that 3 and that 3 cancel. That x plus 4 and that x plus 4 cancel, which gives me my final result that almost doesn't fit, which is x. And because I got x for both of those checks, that means my inverse is correct. All right, my next inverse problem is C. F of x equals 4x minus 3. Actually considerably easier than the last one we did. Now, is that 1-to-1? You know what? It's a straight line. And anytime you have a straight line, as long as it's not a horizontal line, it is 1-to-1. And anytime it has a slope, it's not a horizontal line. So, you know, you could graph it. Down here, y-intercept is -3. Now it's supposed to rise 4 and run 1. So the graph looks like that. Does that pass the horizontal line test? Sure it does, because all straight lines that are not horizontal do. All right, so the next step is I rewrite this as y equals 4x minus 3. Next step, replace x with y and y with x. In other words, do the switch. For y minus 3, I'm supposed to solve for y, so I'm going to add 3 to both sides. Gives me x plus 3 is equal to 4y. Again, if you need to see what I did there, I did plus 3 plus 3. Why? Because I'm trying to get this y by itself. Keep going with it. I got to get rid of this 4, so I divide by 4, divide by 4. And there's my inverse right there. You could write it as y equals x plus 3 over 4. But if I use proper notation, it would be f inverse of x is equal to x plus 3 over 4. Now I'm going to square it off like that's the answer, but I'm also supposed to check it, okay? So when I check it the first way, f of f inverse of x, that's asking me to plug my inverse, x plus 3 over 4, into my original function. So that's going to be 4, remove the x, minus 3. What goes into the x spot? My original function, right? So actually my inverse, x plus 3 over 4. Now, algebraically, those 4's cancel, and I get x plus 3 minus 3, which is equal to x. That's what we're looking for. Now let's check it the other way. So let's check f inverse composite f of x, which means I write down my inverse function, because it's on the outside, parentheses plus 3 over 4. What goes inside is my inside function, which is my original function f of x, 4x minus 3. And then I just do the math to simplify it. Well, in this numerator, this minus 3 and this plus 3 cancel, and I get 4x over 4. And then my 4's cancel, and I get x. So it checked out just fine, which means that is my inverse. All right, next problem is to find the inverse. I know what this looks like, right? It's a parabola because of the x squared. It's shifted right 4 units. And it's telling me I'm only supposed to graph it for x is greater than or equal to 0. So I'd only graph over here. And now I've shifted to the right 4 units. So that means the vertex is right over here at 4, 0 because I haven't gone up or down. And but I'm supposed to graph 0 bigger. So the thing looks like this, right? But if I'm supposed to graph 0 bigger, that means it would start here. But it still fails the horizontal line test. So it has no inverse. And there's nothing else we can do to the problem. If it doesn't have an inverse, it doesn't have an inverse. We can't go any further. But for problem E, again, same parabola, shift 4 units to the right, but it says only graph it for x greater than or equal to 4. There we are, y'all. That guy has an inverse because it passes the horizontal line test. So that means we can keep going with this problem. Remember, first step, rewrite it as y equals x minus 4 squared. Okay? You don't have to worry about writing the restriction down. The restriction is handled in the very beginning, like we just did, and at the very end. And we'll talk about it when we get to the end. Okay, so y equals x minus 4 squared. I'm supposed to solve. Actually, I'm supposed to switch x and y's first, right? X is equal to y minus 4 squared. And now I have to solve for y. So I've got to get this y by itself. To do that, I've got to get rid of this square root. So the square. So let's take the square root of both sides. Now, normally I'd put a plus or minus here, right? But should I? Should I not? It's only going to be one of them. It's either only going to be the plus one or the minus one. Now, right here, when we say x is greater than 4, when we switch x and y, what we know is that y is greater than or equal to 4, because that turns into a y. Well, y'all, if y is greater than or equal to 4, when we cancel this square root and this square, then we're going to be of the right sign anyway, because y minus 4 is equal to 0. If y is greater than or equal to 4, then we're perfectly okay. Okay? So you only need the plus 1. I've actually got another way to help you think about that too. Let me change colors. Okay? Right here, this is x is greater than or equal to 4 on the graph. Also, you can see from the graph, y is greater than or equal to 0. So after the switch, you know what that means is x is greater than or equal to 0. That might make this easier to think about. If x is greater than or equal to 0, then we know that you don't need the plus or minus right here. It's just the plus, okay? You don't need the minus right there. You need the plus right there. So now let's keep going. What we have right now is the square root of x is equal to y minus 4. When I add 4 to both sides, I get the square root of x plus 4 is equal to y. I write that as my inverse, so f inverse of x is equal to the square root of x plus 4. Be sure your square root doesn't carry all the way across to your 4 over there. That's your inverse. But then you're charged with that extra step of checking your work. So to do the check, remember we have to calculate f composite f inverse of x, and we also have to calculate f inverse composite f of x. So in other words, the first one, take your inverse and plug it into your original function. So I have x, I didn't plug in my inverse. My inverse square root of x plus 4 goes into my x right there. So it's going to be square root of x plus 4 minus 4 squared. Right? So I took my whole inverse answer and plugged it in for that little old x right there. Now I simplify this. These 4's cancel. And I get the square root of x squared, and the square root of x squared is x. So it checked that way. Now the other way, that's telling me to plug the whole original function into my x and my inverse. So that'd be the square root of the whole original function, which is x minus 4 squared, and then the plus 4 is on the outside. The square root and the square cancel to get x minus 4 plus 4. The minus 4 and the plus 4 cancel to give me x. And since I got x for both of those, that means my answer down here is correct.